Hello there, welcome back to Lip Tutor. If you're new to the channel, do not forget to hit that bell and subscribe to the channel so as not to miss out on any new videos. Without further ado, let us dive right into today's video. Today, we're going to be learning about naming polyatomic compounds. I'm also going to be sharing tips and tricks on how to remember polyatomic ions. Before we get to naming, let us first define polyatomic ions. These ions consist of groups of atoms that are covalently bonded together. The ions have an overall electric charge. When it comes to naming polyatomic compounds, before you can apply any rules, you have to be familiar with the name of the polyatomic ions, especially the common ones. The table below lists some of the common polyatomic ions. While there's an extensive list of polyatomic ions, there are some tips and tricks we're going to be discussing in today's video in order to help you remember some of these ions better. So, how do you go about memorizing some of these ions? Our very first tip is to know that polyatomic anions, that is, polyatomic ions with a negative charge that contains oxygen, have names either ending with ATE or ITE. The difference between ITE and ATE is indicative of the number of oxygen in the ion. What do we mean by this? Take for example NO2- and NO3-. As you can see, NO2- has less oxygen than NO3-. Thus, when we name it, NO2- is going to be named nitrite, while NO3- is going to be named nitrate. Okay, let us look at another example. SO4 2- and SO3 2-. Just by looking at these two ions, which do you think will have a name ending in ITE and which do you think will have a name ending with ATE? If you guessed SO3 2- is going to end in ITE and SO4 2- is going to end with ATE, then you were right. The chemical name of SO3 2- is sulfite and SO4 2- is sulfate. The next tip or trick to remember is that prefixes are used when series of polyatomic oxyanion extends to 4 members. Specifically, prefixes are used to indicate maximum and minimum number of oxygen. What do we mean by this? There are 2 types of prefixes used when it comes to polyatomic ions. These are per, PER, and hypo. Per is used to indicate one more oxygen than its counterpart ATE, and hypo is used to indicate one more oxygen than its counterpart ITE. With that in mind, let us look at 4 different polyatomic ions: ClO-, ClO2-, ClO3-, and ClO4-. When it comes to naming this, we're going to use a combination of the first and second tip we talked about, meaning we will use ITE to indicate ions with less oxygen atoms and ATE to indicate ions with more oxygen atoms, and add in the prefixes where needed. ClO- is named hypochlorite and ClO2- is named chlorite. Did you notice any pattern or anything? If you notice that ClO- has one less oxygen than ClO2-, then you're on the right track. That is why the prefix hypo is used when naming ClO-, with both having names ending with ITE. Can you make a guess what the name of ClO3- and ClO4- will be? Remember, we said ATE is used to indicate ions with more oxygen atoms. ClO3- is called chlorate, and ClO4- is called perchlorate ion. Again, notice the difference in the number of oxygen, thus the usage of the prefixes per to indicate that. Now, let us look at another series of polyatomic oxyanions that extends to 4 members: BrO-, BrO2-, BrO3-, and BrO4-. Based on the previous example we did, what do you think the name of these polyatomic ions would be? BrO- is hypobromides, BrO2- is bromides, BrO3- is bromates, and lastly BrO4- is perbromates. Guys, if this video has been helpful so far, please don't forget to give it a thumbs up as it helps the channel a lot. Okay, let's dive right back into polyatomic ions. When it comes to remembering polyatomic ions, the last tip to keep in mind is any oxyanion that has H+ ion attached to it will be named by adding a prefix hydrogen or dihydrogen. So let us look at 2 examples. The polyatomic ion HCO3- is made up of oxyanion CO3-2- and H+ ion. CO3-2- is a polyatomic ion known as carbonate. So, as mentioned earlier, the prefix hydrogen is going to be added to the name of the oxyanion. Thus, the polyatomic ion HCO3- is known as hydrogen carbonate ion. Next, we have H2PO4-, which is a polyatomic ion made up of oxyanion PO4-3- and 2 H+ ions. Thus, the polyatomic ion is named by adding the prefix dihydrogen, which indicates the presence of 2 hydrogen atoms. As a result, the name of the polyatomic ion H2PO4- is known as dihydrogen phosphate. While there are a lot of polyatomic ions and they do have to be memorized, knowing the tips and tricks discussed in this video will help you save a lot of time when it comes to memorizing these ions. Being able to recognize polyatomic ions at a glance and knowing the name is essential when it comes to naming polyatomic compounds. Now that we've discussed some tips and tricks to help you in remembering polyatomic ions, we're going to discuss how to go about applying those tips and tricks and naming polyatomic compounds. When it comes to naming polyatomic compounds, the most important thing to remember is that the cation in the compound is named first. For example, if you're given the compound NaNO2, first establish which is the cation and which is the anion. I'm going to put a link somewhere in here on the video where we talked about cation versus anion, just in case you need a little refresher. Okay, back to our example, NaNO2. How do you go about naming that? Na plus is the cation and NO2- is your polyatomic anion. Thus, the name of the compound is sodium nitrite. Let us try our hands at another example. If given the compound FeSO4 and asked to name it, what do you think the name of this compound is? This compound is called iron 2 sulfate. How do we know that this is iron 2 and not say iron 1? This is because we know that the polyatomic ion SO4 has a charge of 2-, and we can see that based on the compound given, we only have one Fe particle. Therefore, Fe, which is your iron, has to have a charge of +2 in order to neutralize the total negative charge of sulfate ion, which is 2-. Let us do one more example. Name the compound NH4NO3. In this example, NH4 plus and NO3 minus are both polyatomic ions. The former is a polyatomic cation, while the latter is a polyatomic anion. Nonetheless, we are going to name the cation first. With that in mind, the name of the compound is ammonium nitrate. When it comes to naming compounds, the more you practice and the more chances you have to apply the different rules and tips, the more you will get the hang of it. And so, in the description box, you will find a link to practice problem as well as step-by-step solution that you can download for free. I'll also put a link to the other videos somewhere in here on naming ionic compounds and binary covalent compounds in case you need revision on those topics. We also have practice problems and step-by-step solution for those topics as well, all of which you can download for free. Just go to the description box in each of the video and click the link. As usual, don't forget to utilize the comment section if you have any questions or need clarification on anything. You can also send us an email directly. In the comment section, I would love to know at least one thing you learned from today's video. If this video has been helpful and you took something away from it, please don't forget to give it a thumbs up. Bye!